Example 1. Determine the horizontal and vertical components of the reaction on the beam caused by the pin at B and the rocker at A as shown in the figure. Now we are one of the assumptions would be to neglect the weight of the beam. So if you can, the first thing that we are going to do is we will express our these forces, no, the corresponding forces that our uh, structural connectors uh, give to our uh, main structure, which is our beam. So it is provided in our Google Classroom that for smooth pins or hinges, and as well as fixed support, they resist horizontal and vertical forces. Anything else for two dimension resist only either vertical or horizontal depending on how the structure is oriented. So knowing that, based on the given, we have 600 Newton going down to the right, applied 45 degrees with the horizontal, and from A, our A and B are at the same level. So from there, we have our 600 Newton is applied 0.2 meters. Now at B, we have 200 Newton, and at D, we have 100 Newton. So if D is at 100, so let us say this point here be our C. Okay, so the first thing that we're going to do is we will draw our free body diagram, right? So we have, let us say this is our beam. We have our A, our B. Uh, it is divided into three sections, right? Okay. So at B, we have 200 Newton. Now at this point, which we will call D, we have 100 Newton going down. Now at 0.2 meters, yeah, 0.2 meters, and also 2 meters from A, we have 600 Newton, and this is 45 degrees, and we will call this point C. Okay, so for our reactions at A, we have A sub Y, meaning reaction only going up. We have B sub Y going up, and we have B sub X. Now for our horizontal component at B, which is B sub X, what we can do is that we can just assume it's a direction. However, if we do some inspection at our forces here, only our 600 Newton force has a horizontal component, which is 600 cosine 45, right? So 200 is going down, 100 is going down. So it means that in order for our structure to be in equilibrium, it must be that our horizontal component of our uh, pin must resist the only horizontal force present, or that is acted on our beam, and that is the x component of our 600 Newton, which is going to the right. So therefore, our x component at B will be going to the left. Anyway, so we have, uh, since we let this as point C, so we have C sub Y, and to the right is C sub X. So of course, our distance of C sub X with respect sa ato ang line AB is 0.2 meters. Okay, now we have learned that we have three equation. The first pair of our equilibrium equation, which is summation of forces x is equal to 0, summation of forces y is equal to 0, and summation of moment at a certain point is equal to 0. Now, we will decide. You guys are given the freedom to choose whatever equilibrium equation to use now, but it is better to have some analysis first in to back up your chosen equilibrium equation. So, if you decide to use summation of forces y, wala problema. However, if we look at our free body diagram now, if we do summation of forces y, we will end up with two unknowns, and that is a sub y going up, b sub y going up, right? So we cannot calculate them. So it is best to move to the next equilibrium equation lang usa, and that would be summation of forces x, for example. Now, if we do summation of forces x, like I said, only two forces is present, and that is the x component of our 600 Newton and our b sub x. So if we do summation, we can ultimately calculate our b sub x. So it is best nga kana lang usay unahon. So that means we do summation of forces x is equal to 0. And assuming, of course, we provide some assumptions again, that is going to the right positive. Now, if you want to do, to assume going to the left positive, wala ra gyapon problema. So that is 600 cosine 45 degrees minus b sub x is equal to 0. So therefore, b sub x is equal to 600 cosine 45 degrees, which is equal to 600 cosine 45, and that is 424.2640687 Newton. So that is our horizontal component at pin B. Next, like I said, if we do summation of forces y now, we will end up with two unknowns, right? So the next best thing to do would be move on to the next equilibrium equation. And since we already did summation of forces x, we will do now summation of forces, no, summation of moment about your chosen uh, point b equal to 0. So we can choose either we do summation at A, at C, at D, or at B. Y Pwede kay ta bisag asa. However, now if you recall, Jod, the reason nga nganong we were not able to do summation of forces y is because if we will end up with two unknowns. So it must be that if we take our moment summation dito ta sa isa ka point nga naay unknown. Kaya para if we do summation, moment summation, usa la ka unknown ang ato ang makita. So it's either we do summation at point A or we do summation at point B. Pisag-asa ra nandira. Now, so let us say I will do moment summation about B. But if you want to do moment summation about A, wala ra gyapon problema. So this is summation about moment B is equal to 0, assuming counterclockwise positive. Now, if you can observe, if we do moment summation about B, we have 100 Newton going down. The Y component of our 600, which is going down, and the X component of our 600 going to the right. Why? Because if you can observe, based on our structure, the uh, our 600 Newton is applied 0.2 meters from this line. And this line is the line that connects A to B, right? And lastly, our unknown, which is A sub Y. So, okay, let us do that. Assuming counterclockwise positive, so that is 100 Newton going down times 2. So let's say 100 times 2 plus what else? And that is the Y component. That is 600 sine 45, 600 sine 45 times, that's 2 plus 3, so that's 5. Now what else? We have the X component, which is with a perpendicular distance of 0.2 meters, and that is clockwise, right? Because it is going to the right. So that is minus 600 cosine 45 times 0.2, and our unknown, which is A sub Y. Now you might notice we did not consider 200 Newton because the line of action of our 200 Newton force together with B sub Y and B sub X passes through point B. And then this is minus A sub Y times 7 is equal to 0. So this is now A sub Y will become positive because I will transfer it to the other side. So this is A sub Y times 7 is equal to, this becomes 200 plus 100 times 2 plus 600 sine 45 degrees times 5 minus 600 cosine 45 times 0.2. Okay, and if you do the solve this one, A sub Y times 7, this is equal to 600 sine 45 is 424 times 5, that's 2,121 minus parentheses 600 cosine 45 times, let me put it in parentheses, parentheses, 600 cosine 45 times 0.2 close. Okay, that's 2,036 plus 20, and that is 2,000. No, not plus 20, minus 20 plus 200. Okay, this is 2,236.46753. Divide both side by 7. So A sub Y is equal to, divided by 7 is 319.4953,614 Newton. Okay, this is our value for A sub Y. Now, knowing our uh, A sub Y, we can now use our second equilibrium equation for set 1, that is summation of forces Y is equal to 0. Because if we do that, only B sub Y will be the unknown. Okay, so if we do that, summation of forces Y is equal to 0, assuming, of course, upward positive. So that is B sub Y plus A sub Y, and then all are minus because going down slantanan, and that is 600 sine 45, 600 sine 45 minus 100 minus 200 is equal to 0. So therefore, we solve this equation in terms of b sub y. That is, b sub y is equal to 600 sine 45 plus 300, right? Because 200 plus 100 and then minus a sub y. Now our a sub y is 319, right? So b sub y is equal to 600 sine 45 plus 300 minus 319.4953614, and that is 404.7687073 Newton. So this is how we solve for any equilibrium problem. Now we don't have to find for f sub b. Meaning the resultant of this equation, these two components, b sub x and b sub y, because it is not provided in the problem. But if you want, you can always do that. Okay?